Here are the answers for the section 5-9 homework. On page 186, we're asked to solve the equation, and we have to check our answers. And the reason it includes this part is our solution process can introduce answers that don't really solve the equation. So number one, we look at all of the members of the equation and find the lowest common denominator. When you have an x, a 2x, and a 6, the LCD is 6x. Let's multiply everything by 6x. The reason for doing that is to cancel the denominators. X cancels x, 2x goes into 6x 3 times, and 6 cancels away the 6. So the new equation that has no denominators is 1 times 6, which is 6, plus 1 times 3, which is 3, and that's equal to 1 times x, which is x. Solving this, we see that 9 is equal to x. But the technique that we used, where we introduced a variable into the numerator, could create an answer that is not correct. So we have to check the answer 9 to see if it truly works. So over here on the side, let's perform a check. We're going to use the original problem. You'll have to ignore where things were slashed out and use the original problem and fill in x with the answer that we think is correct, 9. And over here, 1 over 2 times 9. And we want to know, does the left side equal the right side, which is 1/6? So solving this, we have 1/9 plus 1/18. And we want to know, does that equal 1/6? This denominator is 9 and this denominator is 18. To add fractions, you have to have the same denominator. We can change this to 18 if we times by 2 and in the top. So now this is 2 over 18 plus 1 over 18. This adds to 3 over 18. And 3 over 18 does reduce to 1/6. Our answer checks out, so now we can circle it, x equals 9. Number 3, we have an equation that has fractions. So our technique will be to multiply everything by the lowest common denominator. Looking at the two denominators we have, we can see that one of its factors is 3, and the other factor in the denominator will be 5m minus 4. Let's multiply all members by that LCD. So times by 3, 5m minus 4. And we should put this in parentheses when we do that. Over here, times by 3 times 5m minus 4. The reason for doing that is to do some canceling. The 5m minus 4 cancels 5m minus 4. The 3 cancels the 3. Let's rewrite our equation with no denominators. We have 3 times 3m minus 1. With the distributive property, that's 9m minus 3. And that's equal to, over here we have 2 times 5m minus 4. With the distributive property, that's 10m minus 8. Now let's solve the equation. We could subtract 9m from both sides, and at the same time we do that, let's add the 8 to both sides. So we end up getting 5 equals m. But our technique that we used introduced variables into the numerators that were not originally there. So that could create answers that don't really work. We have to do a check. Use the original problem. So 3 times, where the letter m is, fill in 5. And then minus 1. All over 5 times, where the letter m is, fill in 5. Minus 4. We're wondering, does that equal to 2/3? Let's simplify this left side. 3 times 5 is 15. 15 minus 1 is 14. 5 times 5 is 25. 25 minus 4 is 21. 14 over 21 reduces to 2/3. So it does check out. The answer for m is 5. Number 5, we have the same kind of an equation that has fractions. So let's figure out what the lowest common denominator is. It will have as factors the n minus 4 and the 3n plus 1. Let's multiply both members by that LCD. we should include parentheses around this when we show that multiplying. And over here. The reason you do that is so that the denominators cancel away. Let's create our new equation. On the left side, we're going to multiply the binomials n minus 5 times 3n plus 1 using FOIL. N times 3n is 3n squared. N times 1 is 1n. And negative 5 times 3n is negative 15n. Those combine to negative 14n. And negative 5 times 1 is negative 5. On the right side, we have 3n times n minus 4. Let's use the distributive property. This makes 3n squared minus 12n. Notice how there's a 3n squared on both sides. So when you use subtraction, those will cancel away. Now we could add 14n to both sides. Getting negative 5 is equal to 2n. Then divide by 2. We get negative 5 halves is equal to n. We need to check if negative 5 halves really works. Let's perform our check right here on the paper. The original problem was n minus 5, so where the n is, fill in negative 5 halves. Over, in the denominator, n minus 4. Where the n is, fill in negative 5 halves. We want to know if that's equal to what was on the right side. So 3 times, and fill in negative 5 halves. Over, down in the denominator, it was 3n plus 1. So 3 times negative 5 halves plus 1. We need to perform all this work to see if the left side is really equal to the right side. Because of the fractions, you might want to use a calculator to do this. When I type this entire expression into a calculator, using parentheses to group the numerator and using parentheses to group the denominator, it gives me the decimal 1.15 with some more numbers. When I type this entire expression into the calculator, using parentheses correctly to group the numerator and group the denominator, it gives me the decimal 1.15. So the left side does equal the right side. The answer is negative 5 halves. Number 7 is also an equation that has fractions. We want to multiply everything by the lowest common denominator. But some of them are not in factored form. So our first step will be to rewrite the entire equation and factor all the polynomials. 2 minus y is the opposite of y minus 2. So this expression right here is the same thing as the negative of y minus 2. Notice how there's a negative in front and then a negative here. That could be written as a plus sign. So this middle section is equivalent to this. Over here on the right side, the top does not factor, but the bottom factors as y plus 2 times y minus 2. Now we can get our LCD. There's a y plus 2 and a y minus 2 in the LCD. Let's multiply everything by that lowest common denominator. Now we can cancel things away. Y plus 2 cancels y plus 2. Y minus 2 cancels y minus 2. And both of these cancel away these. Our new equation is 2 times y minus 2, which is 2y minus 4, plus, here in the middle it's y times y plus 2, which is y squared plus 2y, and that's equal to, on the right side, y squared plus 4. Notice how there's a y squared on both sides. So when you subtract y squared, those will cancel each other away. On the left side, we can combine like terms. 2y plus 2y is 4y. At the same time we do that, let's add 4 to the other side, creating 8. Therefore, y equals 2. Now we need to check if that answer actually works. We could substitute 2 where the letter y is in the original equation. However, notice that 2 is one of the restricted values. If you focus on the denominator, for instance, this denominator, y minus 2, and you were to put a 2 in there, what would happen? 2 minus 2 makes 0. We know that a denominator cannot equal 0. Earlier this year, we called that finding the restricted values of the domain. So if y can't equal 2, then this answer that we got doesn't actually work. We didn't have any other possibilities, so the answer to this question is empty set. Number 17, same kind of problem. The first thing we need to do is factor those polynomials to help us get the lowest common denominator. T squared minus 9 factors as t plus 3 times t minus 3. The lowest common denominator will have t plus 3 and t minus 3 in it. Let's multiply all members of our equation by that lowest common denominator. And then cancel away what we can. T minus 3 cancels t minus 3. T plus 3 and t minus 3 cancel those. And over here there was no denominator, so nothing cancels. Our new equation will have 5 times t plus 3, which is 5t plus 15, minus, then 30, and that's equal to 1 times t plus 3 times t minus 3. Remember, t plus 3 times t minus 3 was t squared minus 9. This equation has a variable to the second power. The technique that we've studied in the past to solve that is to put everything on the left side so that there's a 0 on the right side. Let's create a 0 on the right side of this problem by subtracting the t squared and adding the 9. That makes negative t squared plus 5t, and then 15 minus 30 was negative 15 already on this side, and then when we add 9 to it, we get negative 6. And that's equal to 0. Because there's a leading coefficient of a negative sign, let's factor out the negative, which changes the signs of the other terms. Now factor the trinomial using FOIL. We can use t minus 3 times t minus 2. The solution from this first one will be t equals 3, or the solution from this one will be t equals 2. Now, do both of these answers really solve the equation, or is one of them extraneous? When you look at the original problem in black ink, notice that 3 is one of the restricted values. If t was 3, then there would be 3 minus 3, which makes a 0 in this denominator. You cannot have that. So you have to cross out t equals 3. Now, does t equals 2 actually work? It probably does, but let's do a check. We'll do that right here in this space. 5 over t minus 3. And what we're trying for t is the number 2. Over here we have 30 over 2 squared minus 9. We want to know, does that equal to 1? 5 over 2 minus 3 is negative 5. 30 divided by 4 minus 9 is negative 6. And negative 5 subtract negative 6 does equal 1. So our answer is t equals 2. We can circle that. For the review assignment, we're on page 181 where we were solving word problems. Carl can fill a barrel in half an hour. Jim can fill it in 42 minutes. Notice that Jim's time is given in minutes, but Carl's was in hours. Let's rewrite Carl's time as 30 minutes so that we're being consistent with how we're doing time. How long does it take for the two guys to fill it together? The formula we're going to use is work equals rate times time, where the work we're referring to is the job of filling up an apple barrel. The question asks us, how long does it take? It asks us to find the time. Let's use the letter T to represent that. And make substitutions in this formula. In place of work, let's fill in 1, meaning we want to complete one job, or we can think of it as we want to fill up one apple barrel. Part of that work is done by Carl, so let's take his rate and multiply by his time. But what was his rate? Over here on the side, let's define Carl's rate. If he can fill a barrel in 30 minutes, then he can complete 1/30th of a barrel per minute. Since we just figured out Carl's rate, let's also find Jim's rate. We know we're going to need that too. If it takes Jim 42 minutes to fill one barrel, then he can complete 1/42 barrels per minute. Now that we know their rates, let's go back to where we were using the formula. Carl's rate is 1/30th times the time that he's filling the apple barrel. Now add on Jim's rate because he's also doing some of the work of filling the barrel. His rate is 1/42 times the time that he's filling apples into the barrel. Here is our equation that models the problem. Now it's just a matter of solving that equation. The equation has fractions, so the technique that we've learned is to multiply everything by the lowest common denominator. Let's do that in the space over here. First, I want to rewrite the equation and leave myself some room to show that I'm timesing by those LCDs. Now we need to know what is the lowest common denominator if one denominator is 30 and the other denominator is 42. To help us find the lowest common denominator, we learned about LCM in an earlier chapter. If we take 30 and factor it, we can think of 30 as 5 times 6. If we take 42 and factor it, we can think of 42 as 6 times 7. So our LCD must have every factor from the 30 along with every other factor from the 42. So it must have the 5 times 6, which comes from 30, and an additional 7 because 42 also has a factor of 7 along with the 6. 5 times 6 times 7 is the number 210. This process helped us to find out the LCD. Let's times this by 210, times this by 210, and times this by 210. So our new equation is 210 equals, and then let's do some reducing. 30 into 210, 7 times. And 42 and 210 reduce, leaving 5. So this new equation is 210 equals 7t plus 5t. This makes 210 equals 12t. Now divide by 12 to get t alone. 210 divided by 12 makes 17.5. T was a time being measured in minutes. Working together, it takes the two guys 17.5 minutes to fill up the barrel of apples. On page 177, we were solving equations that had fractions or decimals in them. The technique was to multiply by the lowest common denominator. Because there are 3 decimal places after the dot, this is the same thing as 45 over 1,000. This one here is the same as 3 over 100. The LCD of 1,000 and 100 is 1,000. Let's times everything by 1,000 to remove the decimals. So we're timesing this first term by 1,000. We're timesing this middle area by 1,000. And we're timesing the 18 by 1,000. That cancels away the decimal, creating a regular 45y. 0.03 times 1,000 is 30. And 18 times 1,000 is 18,000. Now we have a normal equation like we were doing way back in chapter 2. Let's do the distributive property. We have 45y plus, and then 30 times 500 is 15,000. 30 times negative y is negative 30y. And over here we have 18,000. Now combine like terms. 45y take away 30y is 15y. At the same time we do that, we might as well subtract the 15,000 to the other side, which makes 3,000. Now divide by 15 to get y alone. The answer is 200. Number 10 is also an equation that has fractions. The technique is to multiply everything by the lowest common denominator. That denominator is 1, this one's 2, and this one's 3. The lowest common denominator is 6. So times 6, times 6, times 6. The reason you do that is to reduce. 2 into 6, 3 times. 3 into 6, 2 times. We now have an equation with no denominators. 2 times 6 is 12. 3 times 3 is 9x squared. And over here we have 26 times x times 2. That's positive 52x. This equation goes to the second power. The technique that we know is to make a 0 on one side. So let's subtract 12 from both sides. We have 9x squared plus 52x minus 12 would be equal to 0. Next, let's factor this trinomial using FOIL. Let's try 9x times x to make the 9x squared. And to make negative 12, let's go with negative 2 times positive 6. The reason I used those choices is because the outer product is 54x, and the inner product is negative 2x, and those combine to the 52x. Now take each of those factors and set them equal to 0. And solve them. Add 2 and then divide by 9, creating 2 9ths. Over here you need to subtract 6, creating negative 6. On page 144 we were simplifying complex fractions. It's not immediately obvious it's a complex fraction, but as soon as we fix these negative exponents, you'll see that it is. This is equivalent to b minus a over c. And then in the bottom, it's equivalent to a over b minus c. If it helps you, you can put a 1 under this and a 1 under this. Now it's very obvious that the parts of the expression are all fractions. The technique is to multiply everything by the LCD. If this denominator is a 1, this is c, this is b, and this is 1, then the lowest common denominator has the letters b and c in it. So times this by BC, times this by BC, here and here. The reason for doing that is so that that C cancels that C, and that B cancels that B. Now let's rewrite. B times BC is B squared C, minus A times B is AB. Under the long bar, we have A times C, that's AC, minus C times B times C, that's BC squared. Let's factor this to see if anything will reduce. In the top, it looks like the letter B is in both places, so we can write this as B times BC minus A. In the bottom, it looks like there's a C in both places. we can factor it as c times a minus bc. Now nothing in the top matches exactly with the bottom, but bc minus a is the inverse thing of a minus bc. They do reduce, but they make -1 when they reduce, not a +1. So our final answer is -b all over c. Page 172, we were adding and subtracting fractions. So this is the first skill where we were using LCDs. So let's find the LCD. There's a BC, an AC, and an AB. The lowest common denominator has to have all three letters. We can make this be ABC if we times it by A, and in the top. We can make this be ABC if we times it by B, and in the top. And this last one is missing the C, and in the top. Let's rewrite this so that all the fractions have the common denominator. We have a squared minus b squared plus c squared. And that's all over our common denominator, ABC. Number 16, we're subtracting fractions. Let's figure out the lowest common denominator from 6 and 4. That's the number 12. To make 6 be 12, you times by 2. And in the top. We should put parentheses around that to show that we're timesing both things by 2. Over here, to make this turn into 12, you got times by 3. And in the top. Now let's rewrite. 2y plus 3 times 2 is 4y plus 6. Make sure you think of this negative sign as going with the 3 when you're doing your distributive. So we get -3y minus 9. And that's all over our denominator of 12. Let's simplify the top. 4y minus 3y is y. 6 minus 9 is minus 3. And that's all over 12. Page 169, we were multiplying fractions. This did not take any lowest common denominators. To multiply fractions, you times the top together, you times the bottom. But before you do that, you might look for some reducing. S cancels S. 3 cancels 3, leaving a 1 in there. 2 and 4 reduce as well. 2 goes into 2 once and into 4 twice. I think that's all the reducing. In the top we have 1 times -1, that's -1, and there's an R. In the bottom, there's just a 2 left over. You can write the answer like this, or you can write -R over 2. Number 26 is also multiplying, but this part with the negative exponent, we need to fix that so that we know what's in the top and what's in the bottom. So let's do some rewriting. While I'm rewriting, I'm also going to factor the difference of squares. So this is r plus 2s times r minus 2s over r plus 2s. This right here takes care of this first part, times. Now the part that has the negative exponent gets moved into the bottom. And there's now a 1 on top. Times. And now let's just copy down this last piece the same as it is. Now let's look for any reducing. R plus 2s cancels r plus 2s. R minus 2s cancels this over here. I think that's everything that reduces. So what's left over in the top is 2s, and in the bottom is r plus 2s.